Welcome to the mathematics class. And this time we want to discuss a topic in Form 4 on loci. We start by defining what locus is. And we have the statement already on the board. It is good to note that when we talk about the locus of a point, we mean the path followed by a point as it moves, subject to given mathematical conditions. When we talk about conditions, we are thinking about fixed distance from a given point, fixed distance between two lines, a point that moves so that it's always between two lines, intersecting lines, and many other conditions which we'll be mentioning as we move on. We would like to start with the very basic. The one we start with is going to be the locus of a point, which moves in such a way that it is always equidistant from another fixed point. In real life, this is not a very new situation. You know the clock face. The tip of the minute hand will move. Like we can see in this case. If we take that to represent the clock face, where we have 12 here, we have 1, we have 2, 3, like that, 4, 5, and 6 here, 7, 8, and 9, 10, and 11. We know we have the minute hand. And the minute hand moves. The minute hand will move from here to here, 5 minutes, from here to here, so that now we have a total of 10. We know how the minute hand moves, like that, okay? If you look at this tip here, the white tip, it follows a given path. At one point, it is here, later here, later here, later here, and so on, until we are through with the 60 minutes. The path traced by the tip of the minute hand as it moves around the clock face, that path is the locus of that tip. We can say the tip, the P, that point, moves along a circular path. And in this case, we have the distance, the length of the minute hand is not changing. And therefore, the distance from here to here remains constant. And therefore, the tip of the minute hand traces a circular path. And the center here is not changing. So this is an example of a point that moves in such a way that it is always equidistant from another fixed point. The fixed point in this case is O. Once we have identified the path, we need to describe that path mathematically. So we have an example here. Draw the locus of a point that moves such that it is always equidistant from another fixed point. Now in a question, we would be given that distance. Let's say, for example, we have a point that moves so that the distance is always 3 centimeters from another fixed point. What that means is we would open up a pair of compasses, a distance equal to 3 centimeters. That means you would need to measure that out on a ruler, and then we draw a circle, because we've already noted that if a point moves in such a way that it is always equidistant from another fixed point, then it traces out a circle. So we open up a distance of 3 centimeters. We can mark the fixed point there, and then open out this one so that it is 3 centimeters, and then we complete a circle. There you are. There we have a nice circle, and we can identify a point on the circumference of this circle, which we shall call the P. There, that's the point. So this point is here at one time, it's here after some time, then so describes a circle. And the distance we've been given is here. We can draw, not drawn very accurately, but we can see this is the 3 centimeter. That's the 3 centimeter. And now, how do we describe a locus? The locus of a point P that moves such that it is always 3 centimeter from another fixed point O can now be described as a circle. The locus is a circle, radius OP equal to 3 centimeters. The locus of point P is a circle whose radius is OP, which is equal to 3 centimeters. For your homework, draw the locus of a point P which moves such that it is 4 centimeters from another point Q. Draw that on at home and see whether you are able to get this one right. We will be moving on to the next one in the next lesson, and this one is going to be what we call the parallel line locus. Later we are going to look at the perpendicular bisector locus, the angle bisector locus, the constant angle locus, and after that we will look at questions that lead to that. Until the next lesson, from me it's goodbye.